Hello, my name is Wilma Anak Belfretugu and my matrix number is CF190093, and today I will be presenting about the introduction of this project. A slope failure is a type of natural disaster that occurs when the Earth's self-retainable structure collapses unexpectedly, and it's usually happen due to the earthquakes or rainfall. So there are few types of slope failure, which is translational slide, rotational slide, floor slide, and block or wedge slides. Slope failure causes by the natural forces, human activities, and burrowing animals. These are the causes of slope failure, which is erosion, rainfall, earthquakes, geological features, external loading, and construction activities.
Hello, my name is Evie Avisha Benson. My matrix number is CF191145. I will be presenting about the literature review for our project. In this study, there are several techniques of slope remedial have been designed based on the previous studies conducted. This study mainly highlights the design, material, and its virtue of sorted aspects. In the stability analysis study of conventional retaining walls, variation design in vertical slope, the author mentioned that one of the hazards that usually happen in slope is landslide. This disaster can occur due to various factors such as soil material, load on the slope, and also the presence of groundwater. The author also mentioned that the retaining wall is one of the reinforcement that can help overcome the landslide hazard that is possible to occur. As the outcome of the case study, the greater the retaining wall, the value of safety factor will increase. The outcome also says that the design of the retaining wall with a sloping wall in front of the retaining wall gives higher safety factor than the design of a retaining wall with a slender shape. For the case study on soil nailed retaining walls on hilly area, the author mentioned that soil nailing is a technique that works based on interaction of the soil and the reinforcement bar. Soil nailing is also a construction technique that allows safe overstepping of a new or existing soil slope, or as a corrective solution to make unstable natural soil slope stable. In the study, the author conducted a study in which soil nailed wall was designed. For the outcome of the study, the soil nailed design wall was shown to be more cost-effective for the current case study when compared to the conventional retaining wall. For the third case study, which is a case study on root reinforcement in slope stability models, the vegetation and slope stability are interrelated by the ability of the plant life growing on slope to both promote and hinder stability of the soil. The influence of vegetation on mechanical and hydrological soil behavior represent a significant factor to be considered in shallow landslide modeling. For root reinforcement is widely recognized as one of the most relevant for slope stability. Based on the case study, soil reinforcement occurs when plant root system improve soil shear strength by combination action of large and smaller roots. Roots can anchor the superficial soil layers to more stable substrate, crossing potential plants of weakness, while smaller roots strengthen bonds with soil particles, increasing the overall cohesion of the soil roots matrix. Root reinforcement can work on the landslide, vessel failure plan, or on lateral failure. That is all from my part. Thank you.
Hello, my name is Stephanie Delora Sebastian. My matrix number is CF190140.
Our group proposed two techniques for slope remedial work, which are the construction of retaining wall and the planting vegetation on the area of slope failure. Retaining wall is a structure designed and constructed to resist the lateral pressure of soil when there is a change in ground elevation that exceeds the angle of repose of soil. The lateral pressure could be due to earth filling and liquid pressure. The use of vegetation in promoting slope stability against erosion and landslide is a type of bioengineering that is commonly utilized. Here are some of the advantages of retaining wall.
retaining wall provides necessary support to the soil and also help reduce surface runoff by reducing sharper gradients. This reduces the speed of water traveling over the surface, plus providing effective flood control in form of water drainage aimed to prevent flooding. Retaining walls are economical, durable, and require low maintenance. It is also eco-friendly and gives out an aesthetic beauty to the area constructed. The cantilever retaining wall is composed of reinforced concrete that consists of a wall that is connected to the foundation and is supported by a slab foundation. The slab foundation is loaded by backfill, which stabilizes the wall against overturning and sliding.
Next is vegetation. As deforestation is often part of the course along the geological substrate, intense rainfall and a steep slope and a clear pathway to reach its victim, planting vegetation on slopes is expected to be a part of a solution.
Planting vegetation with deep root systems could prevent landslides as the roots act as physical reinforcement for the soils as it stabilizes and anchors the soil. Trees intercepted raindrops before it reaches the soil, as raindrops hitting the soil surface can cause runoff, especially on rainy seasons. Plant leaves and branches fall to the ground, shielding soil surfaces from raindrop contact and slowing water passage across it. The planted plants also improve slope stability by removing water from the soil. Plants undertake basic metabolic processes such as photosynthesis with the help of water absorbed through the roots. And lastly, vegetation also provides wildlife habitat and food.
Assalamualaikum and hello, my name is Nur Khalisa binti Abdul Rajid. My metric number is CF190171 and I will be presenting about the application of standards. This project highlights two primary techniques of slope remedial that include the implementation of cantilever retaining wall and vegetation technique. Hence, with these techniques come with application of standards, which are the EN 1990-2000 Euro Code and the BS 6031 Code of Practice for Earthworks. The Euro Code standards provide common structural design rules for everyday use for the design of whole structures and parts of works and structural construction or products of both a traditional and innovative nature. The British standard, on the other hand, applies to planning, designing, construction, management, and finally the commissioning of unreinforced earthwork that form part of general civil engineering construction such as highways, railways, and airfields, bulk excavation for both major structures and temporary excavations including trenches, pitch, and shafts. Cantilever retaining wall is a construction that is made up of a vertical cantilever that extends from a big stiff foundation slab. According to the Eurocode, the design of reinforced concrete retaining walls consists of two fundamental stages, namely stability analysis and section design. The stability analysis highlights the principal force operating on the retaining wall, which is the lateral force caused by ground pressure, which can cause it to topple, slide, and settle. There are several parameters in analyzing the stability of cantilever retaining wall. The first parameter is the overturning, the second one is sliding, and the third one is settlement. Overturning occurs because of unbalanced moments when overturning moments about toe due to lateral pressure is larger than the resisting moment of the self-weights of wall and weight of soil above the heel slab. Sliding happens as the friction between the bottom surface of the foundation slab and the earth beneath it provides the primary barrier to sliding, where the resistance produced by massive earth pressure on the base front face contributes some resistance. Settlement analysis, on the other hand, highlights that the base slab's width must be sufficient to convey vertical load to the foundation soil without generating excessive settling or rotation. The use of vegetation or mulches according to the British Standard 6031 Code of Practice for Earthworks, it is the simplest and most efficient method of stabilizing bare soil surfaces. The goal of all surface stabilization procedures is to produce a thick vegetation cover as quickly as possible in order to produce accessible sources of sediment. Soil analysis should be taken into account as well regarding the local soil profile and identify the dominating soil horizon present on the completed surface. pH, salinity, nutrition levels, and texture such as water holding capacity are all factors to consider. The table below provides guidance on minimum and preferred soil depths for various types of planting according to the British standard. And that is all from me. Thank you.
Today, I will be presenting about the long-term stability of technique that have been proposed, which is retaining wall and vegetation. In this part, the long-term stability will be considered by several factors, which is cost, maintenance, environment, and society. Firstly, I will talk about the retaining wall. In constructing a retaining wall, there are some important criteria that need to be considered. It is the external stability factor, the wall height, two-layer soil profile, presence of aquifers, and permissible ground stress. However, the weight of the steel bars are required to estimate the cost of the quantities of the material in the buildings. To ensure the long term of the retaining wall, it needs a good maintenance, which it is important to know few aspects. First, need to know the water problem. When the soil becomes moist, it becomes heavier, which it might put a strain on the retaining wall. To avoid, it can replace the current soil with gravel and line the base of the wall with perforated tile to drain the water out for a better drainage. Although retaining wall can remain for a long time, it needs to be replaced if those indicators occurs. The first indicator that usually happens is cracking. When the cracks is wider and deep, it is a sign of damage. Next is leaning, which caused by the poor drainage or foul footing. Sagging also can appear in retaining wall, and lastly is fogging, which is a sign of built-up water pressure behind the wall. A retaining wall gives an advantages to the environment. It can be used to keep soil from sliding away and also offer erosion management. A retaining wall fills the gap between the existing natural heights of the sandstone at any parts, so that back fence can be built for the safety purpose. Retaining walls also gives an advantage to the society. Building retaining walls can prevent flood control, which provides good safety for the public. Retaining wall can also be used as an ornament. It can make the house more attractive. Next is vegetation. Vegetation did not require a big cost. Vegetation helps stabilize forest slope by providing root strength and modifying the saturated soil by water regime. Plants' roots can anchor through the soil mass into fractures in bedrock, can cross zones of weakness to more stable soil, and can provide interlocking long fibrous binders within a weak soil mass. In maintenance, vegetation has a strong influence on soil qualities such as volume, chemistry, and texture. It influences other vegetational features such as productivity and structures. To prevent surface soil erosion and landslide-style soil movements, vegetation management in urban, wooded, coastal, marine, freshwater, and other riparian zones should retain and maintain plant cover. Water erosion can be controlled by vegetation by restricting surface process like sheet wash and overland flow. By improving soil cohesion, vegetation can make a significant contribution to slope stability. The morphological qualities of root system and tensile strength of single roots are both important factors in root cohesiveness. Vegetation are important to both people and the environment. Humans develop in direct touch with and reliance on plants for food, shelter, and remedies. Hence, vegetation is psychologically essential to them.
Malaysia is known as a tropical country. During the rainy season, landslides have been a major issue in hilly areas. It is critical to focus on the importance of slope stabilization, plans to protect the existing structure on top of slope. The technique proposed will be an aid to improve the safety of those living near a slope, lowering the danger of slope failure, and lowering the cost of preventative maintenance. Retaining wall reduces surface runoff, which reduces the speed of water traveling, thereby preventing erosion. Meanwhile, the use of vegetation strengthens the slope by reinforcing the soil through plant roots, which stabilize the upper section of the soil. In addition, reducing soil moisture through precipitation and transpiration interception.